Hi guys, this is a little short video to help you with your distance learning. So, um, this is the video. Let's get started. Now, before you watch this, make sure you have done your reading of the theory and the examples of the textbook. Otherwise, this wouldn't make any sense at all. So make sure you've done that. And once you've done it, then this is to supplement your study on the coursework that we need to continue on. So this is chapter 4, the transformations and symmetry of the preliminary work. And these are some of the questions that I've selected as a sample to help you complete the work that I've set um, from this section. So this is the foundation part of the question. So the first one that I've selected is question 3, part B. And you were asked to explain this new curve based on y equals x squared, the original parabola. Okay, now notice this is the only difference with the original or the benchmark function is the constant term. Okay, so whenever you have a constant, you will remember from the theory is that the constant here, what it does is basically dragging the original curve up or down by the certain amount, and that is the absolute value in the constant. The negative there means down. If you've got a positive constant, means you're moving up. So you're dragging the original curve, which is y equals x squared, up or down by certain units, then you get the new one, which is this. Okay, so in this case, you're dragging the original one by 5 units down vertically along the y-axis. Alternatively, is you can think of this as, okay, toss the -5 onto the other side because you can't stick it into the x. The only thing you can do with the -5 is shift it over to the other side. Then you get this, okay? And then you think of the value of y that makes the left-hand side 0. Then in this case, it'll be y equals -5. It's similar to the completing the square process, but it's on y, okay? So y equals -5. So that means, again, that means 5. Whenever you have a y, the value that you have to work with y, that means down or up along the y-axis, okay? So that's 5 units down from the origin. So that's how you generate the new one from the y equals x squared, the benchmark. So if you draw that, this is the sketch of it. So the black one is the original or the benchmark parabola. Hence, to get the new one, which is y equals x squared, take away 5, you have to drag the original one down by 5 units. So then you will notice that the vertex becomes 0, -5 at the same time the y-intercept, and you get this parabola. Now, all the while, all you're doing with all these transformations that we're studying in this chapter is that all you're doing is basically preserving the shape, and the only thing that the only move that you make is either move up or down or sideways or the combination of both. You're not doing any stretching or contracting of the original curve. Okay, so that's an important thing to note. That's what's called translation. Moving it just means moving. Okay. All right, next one is this one, question C of the same question. So y equals bracket x plus 4 squared. In other words, this is in perfect square form. So you compare that with the original. So you've got to explain how you get that from that one. Well, this time there's no constant, so there's not going to be any up or down movement. So the only thing that you can do is, okay, come up with the x value that makes the bracket 0, just like the same logic that I applied with the previous one, with the y value. So then obviously x equals -4. Okay, so that means because it's the x value, therefore that associates with the horizontal movement, okay, sideways. So because it's -4, you move to the left from the origin. Okay, so you move to the left by 4 units. Okay, so that's the explanation. You can read that up yourself. So the original curve is this. All right, and because the only thing that you're doing is translating along the y-axis by 4 units to the left, and that's the new one. And let's remember the original axis of symmetry was x equals 0. Now, because it's shifted by 4 units to the left, your new axis of symmetry, or AOS, is now x equals -4. Okay, and the new vertex is now negative 4 comma 0. Okay, so that's that one. And that one, just as a side note, if you put the x equals 0 in there to get the y-intercept, it's going to be 4 squared, which is 16. So that's how you get that. Okay, so still you can apply a bit of, algebra to work out the y-intercept and stuff like that on top of the shifting that we are doing. Okay. All right, next one is question 4. So this time we're dealing with the hyperbola, to be more specific, rectangular hyperbola, compared with the original hyperbola, which is y equals 1 on x. Okay, so again, there's no constant. The only thing that you can work with is denominator. So as usual, you come up with an x value that makes the denominator 0, and obviously that's x equals negative 3. Again, because this is the x value, that means the movement here that's associated is the horizontal movement sideways. So because it's negative, 3 units to the left from the original one. So remember, that's 1 on x. 1 is a positive number, so the original hyperbola will take up the first and the third quadrant with x and y axes both being the asymptotes. Now, like I said, the new curve is created by moving that original one by 3 units to the left. So 3 units to the left, your x's, one of the asymptotes, which is the y-axis, become now x equals negative 3, because you're moving that one by 3 units to the left. So that's going to be one of my new asymptotes. Now, because you're moving it horizontally, there's no change with the other asymptote. Okay, that stays the same. Okay, and therefore this curve in the first quadrant gets shifted by 3 units. So that means it's going to invade or hit the y-axis at some point. And to work that out, you have to put x equals 0, and that's going to be a third. All right, and this one gets shifted by 3 units to the left, so that's why you're getting that. Okay, there's no squashing or squeezing going on. Remember, it's just moving. So this way by 3 units. Okay, all right. The important thing here to the end is still the new one still doesn't touch the x-axis at all, right? Because there's no way for you to get y0 to get the x-intercept algebraically anyway. Okay. All right, next one is this. So that's the constant. So that's very similar to the very first one we had in the parabolic case, which is this one. So the constant there. So that's plus 5. So therefore, remember, that's the dragging up or down along the y-axis. So that's by 5 units up. Or you toss the plus 5 over to the other side, you get this new equation, and then you set y minus 5 equals 0 to get y equals 5. So that's the value of y, meaning the movement is now along the y-axis, either up or down. Because it's positive, it's moving up by 5 units. That's all you got to know to get the new curve. So draw the original one like this, exactly the same benchmark curve we had before in the previous case, and you're now moving up by 5 units. So that's now y equals 5 is now one of the new asymptotes. And notice this time the y-axis stay the same as the other asymptote, because all you're doing is purely moving it up by 5 units, 5 units up. So y-axis as the other asymptote stays the same. So then you're gonna get this and that part. Okay. Again, to specifically work out the x-intercept, you're gonna have to set y equals 0 to that equation or that equation. So set y equals 0, then 1 on x has to be negative 5. So it's a reciprocal. So it's going to be negative 5th. Okay. All right. And the last two are on circles. So we've looked at the circles with the center being at the origin only. So because it's going to involve a bit of shifting along the x and y axis, or it could be both, the center of the new circle isn't at the origin, so it's off the origin. So let's see how that works. So that's the equation for the new function, and you need to explain that from the original one, which is this. Okay, so again here you can't do anything on this y squared, you can't do anything with the 1 put it into the x minus 1 and y because it's all wrapped up by the squaring. So the only thing you can do with this, so find the x value that makes x minus 1 0, which means x equals 1. So it's the x value, therefore it's the movement along the x-axis to the left or to the right. Because it's a positive, so that's going to be to the right. Okay, so that means with the original circle like that, centered at the origin, to get the new one, the only thing you're moving is shifting that one by 1 unit to the right. So that's that one. Hence, the new center will be 1, 0. Radius still the same because that's still 1, you know. So square root of 1 is still the same as 1. So the radius, the size of the circle stays still the same, but it's just a change of the center because the only thing you're doing is shifting to the right by 1 unit. So shape is preserved in all of these exercises. Next one is this. So similarly, it's this time, it's the y value that you need to work out. So y equals -1, so it's the y value, hence it's either move up or down movement. Because it's negative, it's moved down. So this time you're moving down. So again, it preserves the shape of the circle with the radius of length 1, but the center is now at 0, -1 rather, okay, than at the origin. All right, so that about does it for the foundation part of the video, part of the section. And next video will be on, obviously, on some of the questions from the development. Till then, hope you enjoy the questions. See ya.